In this question here, we asked to graph this. We're asked to show zeros, absolute and local min and max. So when we talk about absolute, local min and max, we're going to have to do a candidates list. So we need to make sure we have our candidates list for this. And it also asks for a domain. Now, the domain of this function is going to be based on the square root part of this function. There's restriction on the square root part of that function. In fact, that part happens to be a semicircle. And we have the domain of this function is going to be from -4 to +4. Now, because there is an endpoint, there are endpoints to this graph, we're going to have to include those endpoints in our candidates list. We're also going to put those in as zeros because those endpoints are going to generate zeros. So they're going to get the zeros on the graph. And when we talk about the zeros, we're also going to have a zero come from this factor here. So at x equals 0, we're going to have 0. Okay, so our domain is going to be based on the square root restriction. And then from there, we can see inside and outside that we end up with 0 factors and we get those 0 points. So I'm just going to start graphing some of these points. So I've got 0 here, -4, 0, +4, 0. Okay, so we want to be able to find the min and max points of this, the local min and max points. So we're going to have to differentiate this. So differentiating this, I'm going to get f prime of x. Differentiating the 1, I get 1 times square root 16 minus x squared plus, using my product rule, x times, now this part gets a little bit messy, it's going to be this derivative of the square root. So I'm going to end up with 1 over 2 square root. And then I have to multiply the inside function, the derivative of the inside function, which is -2x. Okay, so we want to simplify this expression. So I'm going to end up with square root 16 minus x squared. Okay, the 2's are going to cancel out. I'm going to watch my signs. So I'm going to end up with minus. In the numerator, I'm going to end up with x squared. In the denominator, I end up with square root 16 minus x squared. Okay, so I want to get a common denominator here to add these fractions. Now, it happens when I get a common denominator, when I multiply the top and bottom by root 16 minus x squared. Well, root 16 minus x squared times root 16 minus x squared, that's going to cancel out the square roots. So my derivative then is going to look like this: 16 minus x squared minus x squared, and that's all over the common denominator of square root 16 minus x squared. Okay, so I'm going to simplify this. So I'm going to end up with 16 minus 2x squared all over square root of 16 minus x squared. And that's going to simplify to 2, 8 minus x squared. Okay, so if I want to know where this is equal to 0, I look in the numerator, and it's equal to 0 at x equals plus and minus square root of 8. Okay, so I have non-differentiable points at the endpoints. Okay, so those are non-differentiable points. So I'm just going to start plugging into my derivative expression here. So those are non-differentiable points at the end. I have a derivative at -root 8. I have a 0 derivative there at positive root 8. Okay, I have a 0 derivative, and at the endpoint +4, it's not differentiable. Okay, and it makes sense because that is an endpoint anyways. So since I have plus minus root 8 as my 0 derivatives, I should really put those into my chart here. And I'm going to do a derivative test to test the slopes in here. So f prime, I'm going to choose some number between -4 and -√8. So I'm going to use -3. Calculating the derivative at -3, when I plug it into that expression, I get 8 minus -3 squared, which is 9. That's going to give me negative. And then the denominator is a square root function, so that's going to be positive. So I'm going to end up with negative slope. Okay, so in here, at -3, I'm going to have it sloping down. Okay, I'm going to test my slope at 0. So when x is 0, I'm going to end up with positive on the numerator, positive in the denominator. So that's going to be positive slope through that region. So it looks like that is a minimum. The positive √8 looks like it could be a max. I'm just going to test this here. So a number between √8 and 4. √8 is about 2.8, so that's why I'm using the number of 3. So when I plug in 3 in there, I'm going to end up again with a negative on top, and then the denominator is always positive, so negative slope through here. Okay, so it's going to slope down to that endpoint. So it looks like I have local min and maxes at -√8 and positive √8. So I'm going to plug those into my expression. When I plug those into the expression, I'm going to have 16 minus √8 squared. So that's going to be 16 minus 8. So that's going to be square root 8. And then I plug in my -√8 into the x. So I'm going to get -8 as my y coordinate. So I'm just going to sketch that in. So -8 is going to be about there. So that's going to be about √8 right about here. Okay, so that's about -√8. So I'm going to have positive √8 somewhere around here. And when I plug that in, I get positive 8 for my coordinates. So it's going to be somewhere about here. And we know those are local min and max points. Okay, so that's really all I need for that, for my graph. I could pretty much graph this at this point. Okay, so I can sketch in my graph. I've got my slopes. Okay, so I'm going to sketch it in. There's my local min. It's going to go through the 0 here, go up through my local max, and come down. I can see that those represent my absolute min and max points. When I put this all into my candidates list, I get 0, -8, 0, actually that's going to be negative, +8 here, and 0 here. I can see that that is my absolute min, and this here represents my absolute max.